My dear viewers, you are most welcome to Algebra 2 Mathematics channel, and thanks for watching. Welcome to lesson 4 of our topic, which is none other than equations of straight line. And please, if you are on this channel, kindly subscribe, turn on the notification button so that you are notified whenever I upload a new video, like and share. In this video, we are going to fully cover the following. We have number 1. We are going to learn how we draw a straight line passing through any two given points. We are going to also learn how to obtain the equation of a line given the gradient and the y-intercept. Also understand or learn how we obtain the equation of a line given the gradient and the point on that very line. Also, we have to obtain the equation of a line given 2 points on it. Obtain the equation of a line which is parallel to a given line and passing through a given point. Then lastly, we shall learn how we obtain the equation of a straight line which is perpendicular to a given line and passes through a given point. So now let us dive into the video, and please watch up to the end so that you don't miss out anything or any step. So let us begin with our first one, which is none other than drawing a straight line. So how do we draw a straight line? We are saying that when given 2 points, for us to draw a straight line, we simply need the 2 points lying on the line. And then thereafter, we plot the points and then join them using a ruler. So we draw a straight line joining the two plotted points. Let us have an example here. Draw a line that passes through the points. We have Roman number 1 up to Roman number 3. And we are going to draw the straight lines passing through them. In here, as you can see, we need to draw our Cartesian plane with the axis. So now this is our Cartesian plane. We can label the axis. This side we have the x-axis. Then the y-axis is here. Don't forget to label them. Then for Roman number 1, we need to draw the line passing through these 2 points, and the steps we are going to follow first. We are going to first plot the points. That's why I'm saying plot the points. After plotting the points, we are going to join the plotted points. So part B, we are going to joining the points using a ruler. And then we shall have come up with a straight line passing through those plotted points. For my number 1, let us plot. We have to plot 0, 2. So 0, 2. It's here. That's where the point is. Then 2, 4. 2, 4. It is simply here at that point. Then we need to join those two plotted points using a straight line. Let me draw it using a red ink. From here, I'm drawing it. So now this is our line for Roman numeral 1. Let us proceed to Roman numeral 2. We have to plot negative 3, negative 3. So negative 3 on the x-axis and also negative 3 on the y-axis. So the point is simply here. There we have plotted, and this is the negative 3 as the point. Even here it was 0, 2. Then here it was 2, 4. So in here we have so far plotted negative 3, negative 3. We need also to plot 1, 5. So 1, 5. It's gonna be here. This is 1, 5. Then we need to draw a straight line passing through these 2 points which are plotted. We are going to use, let me use blue, the blue color. So I'm going to draw a straight line from here joining to this point here. And now that becomes our line for Roman number 2. And simply I can label it using a green pen. This is for Roman number 2. Then for Roman number 3, we have to plot the points 2, 3. So 2, 3, 2, 3. 2, 3 is here at this point. So it is 2, 3. Then 4, negative 1. 4, negative 1. It is simply here saying this is 4, negative 1. Then we are going to join. Let me use a green ink to join those points from this point to this one. So that is our straight line for Roman numeral 3. I can label it as Roman numeral 3. So that is how one could draw the lines passing through these two given points. Let us have to our second learning outcome, which is drawing a straight line whose equations are given. And likewise here we have Roman numeral 1 up to 3, and these are the steps we follow for us to draw the line whose equations are given in here. Let us have for Roman numeral 1. Our equation is y, take away the 2x minus 3 equals to 0. What we do, we are going to have the x here and the y. This is what I'm meaning. We get some values of x. For example, if x is 0, then what would be y? So this is what I say, that for x equals to 0, from this equation y minus the 2x minus 3 equal to 0, what's gonna be our y? So we substituting that y minus the 2 multiplied by 0 minus 3 equals to 0, implying that our y is gonna be minus 3 equals to 0. So our y in this case is gonna be the positive 3. So when x is 0, y is 3. Then also we can try some other values. What if x is 1? So if x is 1, what is gonna be our y? As we substitute in still, so for x equals to 1, then what is our y value? Then from y minus the 2x minus 3 being equal to 0, as we substitute, we are going to have our y minus the 2 into 1 minus 3 equal to 0. It means that we are going to have our y minus the 2 minus 3 equal to 0, implying that our y is going to be equal to the positive 5. So it means that when x is 1, then y is simply 5. What if when x is negative 1? So the same way, we are saying that for x equals to negative 1, what is our y value for this case? So still from this, y minus our x value minus 2 into our x value, which is negative 1 minus 3 equals to 0. So as we simplify, we have our y plus the 2 minus 3 equals to 0, implying that we have our y minus 1 equals to 0, implying that our y equals to 1. So it implies that when x is negative 1, then y is 1. So we have our 3 points that we can have. So the points to plot, we can have like a 3 or 2, a minimum of 2. But here we have got 3. So we are going to plot the points, which are, we're going to plot 0, 3, then plot 1, 5, and also plot negative 1, 1, for us to come up with a line whose equation is the y minus 2x minus 3 equals to 0. So having got the points to plot, we need to draw the Cartesian. This is our x-axis, and then the y-axis is this side. So we have to plot points or coordinates 0, 3, 0, 3, it's here, and this is the 0, 3, then 1, 5, 1, 5, it is here, it is the 1, 5, plotted, then negative 1, 1, negative 1, 1, it is here, this is the negative 1, 1. Then from here we are going to join using a straight line. Let me use a red line. Going to join a straight line passing through these 3 points. We can even extrapolate. So this becomes our line, and let us label it. So this line is the line which is y minus the 2x minus 3 equals to the 0. So that is for Roman numeral 1. We can now go for Roman numeral 3. I mean 2. Remember our equation is y equals to 3x minus 5. Roman numeral 2. I mean we have y equals to the 3x minus 5. Let me reverse. That is it. Still we need to get some points to plot. We are going to have the x and the y here, and we are saying that for when x is 0, what is our y value? So for x equals to 0, our y value is going to be equal to the 3 multiplied by 0 minus 5, implying that our y is going to be equal to the negative 5. So for x is equal to 0, y is negative 5. Then for when x is 1, what is our y value? So for x equals to 1, our y value is going to be equal to the 3 multiplied by our x, which is 1, take away the 5, implying that y is going to be equal to the negative 2. So this is negative 2. So having got so far now the minimum values or points to be plotted, we can proceed with those. Then they say that the points to plot, points to be plotted. So we are going to have the 0, negative 5, also have the 1, -2. So the next step is to draw our Cartesian. From the Cartesian plane, this is the side of the x-axis, then this is the y-axis. So we are going to plot the coordinates 0, -5, 0, -5, it is here. So this is the 0, -5, then 1, -2, 1, -2, it is there. Sorry, let me make it accurate. It is 1, -2, so it is there. Then let me draw a straight line passing through those two potential points. Let me make it red in color. So this is our line, and you can now label it that line, that this is the line whose equation is y equals to the 3x minus 5. Let us go to Roman numeral 3. Roman numeral 3. Still the same way, our equation is the 2y minus 2x plus 3. This must be something here. Maybe equals to 0. Yeah, that is a point of correction. And try out Roman numeral 3. So having looked at how we draw straight lines when given the equation, let us go ahead and look at, so let us talk about the equations of a straight line. And the equation of a straight line is in the form y equals to mx plus c, where m is the gradient. As you can see here, m is the gradient, c is the y-intercept. That's what we are saying. And when the above equation is drawn on the Cartesian graph, as it appears below, we can see that the y-intercept is simply at this point here. As you can see, it is shown by this arrow here, and it is the point where the line cuts the y-axis, whereas the x-intercept is where the line cuts the x-axis, as you can see. In this line of this equation is seen cutting the axis, the y and x-axis or axis. When it cuts, the point where it cuts the y-axis called the y-intercept, whereas the point where the line cuts the x-axis is called the x-intercept. Let us have a subheading of how we can obtain the equation of a line given the gradient and the y-intercept. Let us have our response here. Simply for Roman numeral 1, we have been given our m, which is the gradient, as 3, and then the y-intercept c as -2. Remember, they say that the general form of our equation is y equals to the mx plus c. So simply we are going to substitute in. So we are going to have our y being equal to our m, which is 3, multiplied by x, plus our c, which is -2. So when you modify this, the same as having y equal to the 3x minus c at 2. So this becomes our equation for Roman numeral 1. So let us have Roman numeral 2 in here. For Roman numeral 2, we've been given m, the gradient, as 3 divided by 2. Then the y-intercept, which is c, as 3. So we have to substitute in this general form of the equation plus c. So we have now our y being equal to our m, which is 3 divided by 2x, plus our c, which is 3. So we can leave it at this stage, or if not, we can eliminate the denominator by multiplying through by 2. So as we have the y equal to the 3 out of 2x plus 3, to eliminate the denominator, or simply we are going to multiply by 2 everywhere. So by 2, so that we have the 2y equals to the 3x plus the 6. So this is correct, and also when left at this step, it is also correct. Let us have Roman numeral 3. Our m is given as -4, whereas our c, the y-intercept, is given as -3 out of 4. -3 out of 4. Still, we are substituting in our general form of the equation, which is y equals to mx plus c. So in here we have our y being equal to our m, which is -4, multiplied by x, plus our c, which is -3 out of 4. So this becomes our equation, or one can go ahead and modify it by simply multiplying through by 4. So multiply by 4 everywhere. So -4x multiplied by 4. Then this is a -3 out of 4 multiplied by 4. Let us now proceed to example 2, which reads, obtain the gradient and y-intercept of the line whose equation is this. So we've been given the equation in here, and they want us to determine the y-intercept. and then the gradient. So simply, in our response, what we are going to do, we are going to rewrite this equation, which is the 4x minus 3y minus 9 equals to 0. So we are going to rewrite it or modify it such that it is in this form, which is y equal to mx plus c, whereby the m is the gradient, shall be in position to identify it, then the c is the y-intercept. So we simply going to modify it. So we make y the subject in this equation. Simply we need to modify this. We have the 4x minus the 3y minus 9. Let us take 9 this side on the right hand side of the equal sign. So we need to add it on both sides. So equals to 0 plus the 9. So this and this, they cancel out and remain with the 4x minus the 3y equals to the 9. We need to make y the subject. Simply we are going to take the 4x on the right hand side. So for the 4x minus the 4x minus the 3y equals to the negative 4x plus a 9. So this and this, they cancel out and remain with the negative 3y being equal to the negative 4x plus 9. So to make y the subject fully, we are going to simply divide it through by negative 3 on both sides. B, which is obtaining the equation of a line given the gradient and a point on the line. So let us have our response here. Been given the gradient and then 1 point. How do we get the equation? So for Roman numeral 1, we are going to say that from m equals to the y minus y1 divided by the x minus x1, and for Roman numeral 1 been given point A, which is a coordinate having the 3, negative 4. So in here, this is the x-axis value, and then this is the y-axis coordinate value. So simply it means that this is y1, and then this is x1. From here, we are going to substitute in. Remember, we've been given our m, which is the 3. As we substitute in, we are going to have the 3 being equal to the y minus the y1, which is negative 4, divided by the x minus the x1, which is the 3. So from here, we need to simplify by cross multiplying. So we are going to have the y minus, so this becomes now plus, since it is a minus and the minus becomes a plus, so plus 4 being equal to the 3 into x minus 3. As we simplify, we are having y plus the 4 equals to the 3x minus 9. Let us make sure that this 4 crosses the equal sign and it goes on the right hand side. So we have y plus 4 minus 4 equals to the 3x minus 9, then minus a 4. So we have y being equal to the 3x, then negative 9 minus 4, we are getting negative 13. Therefore, the equation becomes this. So this is our correct answer for Roman numeral 1. We can now go in for Roman numeral 2. Roman numeral 2, we've been given our m as negative 3 out of 2, negative 3 out of 2. Then the point B as 5, 4. Let me cross check. Yes, still from y equals to the mx plus c, we can use this formula also to get the answer, whereby this is the x value and then this is the y value. Simply we are looking for c. So in here we are going to substitute in. It means that our y is 4 equals to our m, which is negative 3 out of 2, x, and our x is 5 plus c. So we want to get the value of c. Simply we have now negative 15 divided by 2 plus c equals to 4. I've just interchanged. I began with the one on the right hand side. So simply to make us see the subject, I'm going to have our negative 15 out of 2 plus 15 out of 2 plus c equals to 4 plus 15 out of 2. So this and this, they cancel out and we remain with our c on the left hand side being equal to the 4 plus 15 but out of 2. In here we need to simplify further. So our c is gonna be equal to, so the LCM is 2. Since here we have a denominator as 1, 2 divided by 1 is 2. Multiplied by 4, we have 8 plus 2 divided by 2 is 1. Multiplied by 15 is 15. So as we simplify, 8 plus 15, we are getting the 23 out of 2. So this is the value of C. And to get our equation, we just need to substitute in. So we are going to have our Y being equal to, remember our M is negative 3 out of 2. So negative 3 out of 2. X plus our C, which is 23 out of 2. So this one becomes our correct answer. Or if not, one can modify it further by multiplying through by 2. Everywhere. So that at the end we shall have the 2y equaling to the negative 3x plus 23. This one is also correct. So that is Roman numeral 2. Let us have Roman numeral 3. Roman numeral 3. Remember our M is given as negative 4. Then point C is 2, 6. So we have M as negative 4. Then the point is 2, 6. Still from the y equals to the mx plus c, we are going to substitute in whereby the y is equal to the 6 and then the x equals to the 2. We look for the value of c, which is the y-intercept. As we substitute, we are going to have 6 being equal to our m, which is negative 4, multiplied by our x, which is a 2, plus c. As beginning with this, we are going to have our c minus 8 being equal to 6. To make a c the subject, we are going to move the 8 on the other side. So we have now this side 6 plus the 8. So this and this, they cancel out and remaining with c on the left hand side being equal to 8 plus 6. We are getting 14. So now as we substitute in, our equation is going to be y equals to the negative 4x plus our c, which is 14. So this therefore becomes our equation from Roman numeral 3. Let us now have our new subheading, obtaining the equation of a line given 2 points on it. So in here, we are going to use a certain formula, like as a response. We are going to have the formula that from, this is Roman numeral 1, from that y2 minus y1 divided by the x2 minus x1 equals to the y minus y1 divided by x minus x1. So in here, we've been given the points. We have A at 1, negative 1, then B at 2, 3. We can make this to be x1, this to be x2, then this one automatically becomes y1, then this is y2. So simply we are going to substitute in. So where y is just arbitrary value or arbitrary points in the Cartesian plane. So y2 is the 3 minus the y1, which is negative 1, divided by x2, which is the 2. Take away the x1, which is 1, should be equal to the y minus, but negative 1, then divided by the x minus 1. So as we simplify, we are having the 3 plus 1 divided by 1 equals to the y plus 1 divided by x minus 1. So as we proceed, 3 plus 1 is a 4 divided by 1 equals to the y plus 1 divided by x minus 1. The next step here, we are going to cross multiply these two. So as we cross multiply, we are having our y plus 1 equals to the 4 multiplied by the x minus 1. Y plus 1 equals to the 4x minus 4. We can take this one on the right hand side. So we have y plus 1 minus 1 equals to the 4x minus 4, then minus 1. So our y equals to the 4x minus 5. Therefore, this becomes our correct answer for Roman numeral 1. So our Roman numeral 2, we have the coordinates at negative 3, negative 3, and let me cross check, negative 1, 1, negative 1, 1. Likewise, you can make this to be x1. This is now y1, x2, and then this is y2. Still from y minus y1 divided by x minus x1 being equal to the y2 minus y1 divided by the x2 minus x1. So from here, we simply going to substitute in. So y minus the y1 is the negative 3 divided by the x minus the x1, which is negative 3, equals to the y2, which is 1, minus the y1, which is negative 3, divided by the x2, which is negative 1, minus the x1, which is negative 3. So we need to simplify. So we have now y plus 3 divided by x plus 3 equals to 1 plus 3, which is now becoming 4, divided by 2. From here we are going to cross multiply so that we can have the 2 into y plus 3 being equal to the 4 multiplied by the x plus the 3. So in here we can divide it through by 2 first. So divide it through by 2, divide it through by 2. So we have y plus 3 being equal to the 2 into x plus 3. So y plus 3 equals to the 2x. We can now proceed to Roman numeral 3. We have 3, 4 and 5, negative 6. Roman numeral 3, we have 3, 4 and let me cross check, and 5, negative 6 and 5, negative 6. So from here this is gonna be the x1, automatically this one becomes y1, this is x2, then this is y2. So from y minus y1 divided by x minus x1 equals to the y2 minus y1 divided by the x2 minus x1. As we substitute in, this is the same as having the y, take away the y1 which is 4, divided by the x, take away x1 which is 3, should be equal to the y2 is negative 6 minus the y1 which is 4, divided by the x2 which is 5, take away the x1 which is 3. As we simplify on the left hand side, we have the y minus 4 divided by the x minus 3 should be equal to, so this is the negative 10 divided by 5 minus 3 is 2. So we have now y minus 4 divided by the x minus 3 should be equal to, as we reduce by 2, we are getting negative 5 out of 1. Then from this step, we need to cross multiply. So from this step, we are having our y minus 4 equals to the negative 5 multiplied by x minus 3. So we have y minus 4 equals to the negative 5x plus, it is because negative and a negative when multiplied we get a positive, so plus 15. From here we can take this negative 4 on the right hand side, whereby we are going to add it on both sides. So equals to the negative 5x plus 15, then plus 4. So our y equals to the negative 5x plus 19. Therefore, this becomes our correct equation for Roman numeral 3. We can now go ahead and look at the next subheading, which is obtain equation of a line which is parallel to a given line and passes through a given point. We have the example that write down the equation of the straight line passing through. We have Roman numeral 1. Let us have our response here. For Roman numeral 1, been given the point as 5, 11, and they say it is parallel to the x-axis. So what we have to know about parallel lines is that parallel lines have the same gradient. And if it is parallel to the x-axis, remember x-axis has a gradient of 0 or has no gradient, implying that the equation of a line passing through this point and parallel to the x-axis is simply a line which is through y equals to 11. So simply this is the equation of that line, whereby there is no x, implying that it has no gradient, or the gradient is 0. Like for the form of the equation, linear equation mx plus c. So if m is 0, simply we are going to just have the point or the y-intercept, which is the point at which the line cuts the y-axis. Therefore, for Roman numeral 1, this becomes our equation. Let us now move to Roman numeral 2. They are saying that we determine the equation of a line passing through 0, 1, and parallel to this line. So if it is parallel to this line, whose equation is 3x minus 2 plus 5y equals to 0, what we need to do, we need to first get the gradient from this equation. Remember, we've been given the point as 0, negative 1. So we need to modify this to be in the form y equals to the mx plus c, so that we can tell which is the gradient. So let us modify this equation. Simply, we're going to make y the subject. So from the equation here, we are going to have the 5y being equal to the negative 3x plus 2. So our y is going to be equal to the negative 3 out of 5x plus the 2 out of 5. So in here, we can see that our m, the gradient, is negative 3 out of 5. And since these lines are parallel, it simply means that we now have the gradient of the line which is passing through this point is also this. So the line passing through this point 0, -1 is also -3 out of 5. So simply we are going to apply our method, which is m equals to the y minus the y1 divided by the x minus x1. Or we can use the other way around just by substituting in this form. We first get the value of c, which is the y-intercept. Thereafter we substitute in to get the equation of the line they want. So from here, remember our gradient is -3 out of 5 equals to the y minus our y1 now can be -1, then divided by x minus our x1 be 0. What we are left with is just simplifying. So we have -3 out of 5 being equal to the y plus 1 now divided by x. We are going to cross multiply. So in here we are going to have the 5 multiplying the y plus 1 equals to -3x. We need to divide 0 by 5 so that we have the y plus 1 being equal to the -3 out of 5x. We need to take this 1 on the right hand side so that we have the y being equal to the -3 out of 5x minus 1. Therefore, this becomes our equation for that part, which is Roman numeral 2. So you can try out the remaining Roman numerals, which are Roman numeral 2, 3, and then Roman numeral 4. Let us have our very last subheading, which is obtaining the equation of a line which is perpendicular to a given line and passes through a given point. So if two lines are perpendicular, what we have to know, if one line is having the gradient as m1 and another line is having the gradient as m2. If these two lines are perpendicular, then the multiplication of the gradients of their gradients should be equal to the -1. So this is what we are going to use for this case. So I said I'd write down the equation of the straight lines passing through the points. We have Roman numeral 1. The point is 0, -2. And they are saying that it's perpendicular to the line whose equation is this. So we've been given the equation as 4y equals to the 2x plus 3. So as we modify this equation, this is the same as having the 2x divided by 4 plus the 3 divided by 4. As we reduce, we are going to have y equals to the half x plus 3 out of 4. So in here, our m is equal to, maybe m1 is equal to a half. Then since they are perpendicular, we need to look for m2 maybe, which is now the gradient of the line passing through this given point. So we can say that let the m2 be the gradient of the line that passes through 0, -2. So since they are perpendicular, we're going to have m1 multiplied by m2 should give us -1. But we have our m1 which is equal to a half, implying that as we substitute, we are going to have a half m2 being equal to -1. To make m to the subject, we are just simply going to multiply by 2 both sides. So we have m2 equals the -1 multiplied by 2. So our m2 is coming to be the -2. So this is now the gradient. Then we are going to use the general form of a linear equation, which is y equal to mx plus c, and the point 0, -2, and the m which is equal to -2, and get y. Thereafter we substitute to get the equation of the line they want. So we are having our y, which is -2, equals to our m, which is -2, multiplied by x, which is 0, plus c. We can see that our c equals to -2. What does it mean? As we substitute in, it means that our equation is that y equals to the -2x, then minus the 2. This -2 is now the y-intercept. So therefore, this becomes our equation. You try out the last Roman numeral, and please, thanks for watching. See you again next time. Goodbye.